Hello, statisticians. So I realized that I think the technology plus the new content was a lot to do on one day. So I decided to go back and actually make you a video for this subject or this topic, just to help you out a little bit more with it. So we're going to talk about the language of variation. That means what ways can we describe variables? So, the first thing that's important is to be able to identify who our individuals are in a table or a data set and what our variables are. These individuals are the objects being described by the data. And it's tempting to think of this as people because so often we are describing people and humans uh, as our subjects. But that's not necessarily always true. It's just whatever objects we're describing. The variables we're working with are the characteristics of those individuals. So the individuals are what is being described. The variables are how we are describing that. So let's look at one of our examples from the homework. It was the first table. It's got some states, and we actually included the United States in there. And then we've got some facts about those states. So in this table, our states and the United States, those geographic locations, one might say, are our individuals. We're describing Texas based on the variables area, population, average income, and region. We're describing New York and Michigan and Wyoming and the United States based on these variables that we're given. Okay, so there are two main types of variables. The first is going to be our categorical or our qualitative variables. When you think of a category, we are describing an individual by placing them into a group. Really, think categories, that game you used to play when you were a kid. We're describing how somebody fits into a box compared to the other individuals. Quantitative or numerical variables are our variables that take on a numerical value, and it makes sense to do operations on those values. So you think of quantities, think of how much of something there is, how many people there are. But not all numbers are quantitative. Zip codes are numbers, but we don't find an average zip code. Coffee sizes are numbers, 12 ounce, 16 ounce, 20 ounce. If you're feeling really bold, maybe you want to go for that Trente, that 30-ounce coffee. But we're not going to say the average coffee size for a day. So those numbers are actually categorical. So when you're looking at a number, think to yourself, would it make sense to average this value? Would it make sense to do numerical operations on these values, these numbers? Similarly, some numbers can be both categorical and quantitative. For example, if you think of your STAR test score, you definitely got a value. We can find the average test score, or we can separate those scores into ranges that we describe by categories. We can clump, 80 and above is exceeding expectations. Maybe 70 to 80 is meeting expectations. And maybe below a 70 on a test would be not meeting expectations. So now we've taken these numbers and we can think about them in both ways, as categories and as quantities or averages. So let's go back to our example. We know that top row describes our variables. There's an obvious categorical variable. We know that the region is not numerical. I cannot find an average region for these states or these locations. The other three are all numerical. So we need to think, are these things I would find an average for? Well, yeah, we could find an average size of states. It might be a little weird because we have things like states like Rhode Island, which are so tiny, and states like Texas and California, which are massive. We also have population. We can find an average population, and we often compare populations of different cities and states and countries even. The average income has already been averaged, so it obviously makes sense to break that into a quantitative value or a quantitative variable. So now we've separated into these two types of variables. We can explore our quantitative variables with even greater detail. There are discrete variables, discrete quantitative variables, where your values can only be certain numbers. You can only take on a certain value. For example, an Amazon rating, I can't go on Amazon and say, I was kind of happy with this product, but also kind of disappointed, so I'm going to give it 2.7 stars. I can't do that. I have to give it either a 2 or a 3-star rating. But then Amazon takes everybody's rating and they average them to find a mean rating, and that's what you see when you look on the product page. 4.26 is our average rating, or they actually like shade a portion of the star, right? So they find the mean of that product. Copa, stop. They find the mean of that product, but we have to choose one of a specific value. There are also continuous variables, which when you think back to Algebra 1, that may help you when determining if variables are discrete or continuous. But our continuous variables take on a value in a range. They can take any value within that range. So, for example, think of your test scores. Again, just because your grade gets rounded to like a 94 does not mean that it's discrete. Your grade actually was calculated as a 93.7, but when you look at it, it rounded up. So don't think that every value that's an integer is discrete. Think about, would it be possible to take on a value in between? Is it possibly only presented as an integer for ease of understanding for the reader? Because occasionally things are rounded, like quite often, in fact. Now, if we look back at our example and our 3 quantitative variables, area, population, average income, those are all like very fluid numbers, right? So when we're looking at the population in millions, we know realistically we cannot have 1.2 humans. But when we look as far as millions go, that is where we get to have these decimals, and the way we're looking at it makes that appear continuous. Average income, also continuous. Area, also continuous, even though it says the size of Texas is 268,820 square miles. Maybe it's all of that plus 1 inch, plus 1 square centimeter. We don't know. For ease of reading, we're going to round all of these values. So these are all 3 actually continuous. So when you are completing your assignment, really take note of those notice and wonder questions, because we're going to start talking about distributions next week. And I want you to get used to looking at one variable maybe, and then maybe comparing variables. Start noticing patterns and relationships between those variables, because that's really going to help you out when we start talking about distributions. So remember, individuals, what's being studied. Variables, how we're describing those individuals. Quantitative, we can do operations on that. Categorical, we're putting people into buckets, or putting individuals into buckets and grouping them. Okay, reach out if you have any questions, comments, concerns. Text me on Remind, message me on Canvas. Have a wonderful weekend and keep on learning.